and we should be live. I know there's like a few seconds delay going over to YouTube, so I'm just going to make sure that it does start streaming over there, and then we'll get going. While we're waiting real quick, anyone in the audience, it's always fun to see like where people are watching from. So if you want to post in the chat where you're watching this from, and also if you want to post maybe if you've had any experience with no-code machine learning systems, that would be fun to hear as well. So if you're just joining and you want to post in the chat, you can introduce yourself, say hello, say where you're watching from, and if you've ever used any no-code machine learning or low-code, which we can talk about the differences in a little bit.
Mm-hmm.
And
Yeah.
all right, so I'll start with an introduction. My name is Sage Elliott. I'll be the host for today's Robust and Responsible AI event. We're a community of AI machine learning practitioners, researchers, designers, and much more, really just anyone working in the AI field. You can think of this event kind of as a live podcast, so I'll be interviewing guests, starting with a specific topic, and then we might go into other topics depending where the conversation goes. And if we have time, we can probably take some questions at the end about the topics. And also, I always like to say, if you want to come on for an event like this, let me know in our Slack channel or the talk request link in the description. So again, I think most of the links we'll probably reference are going to be in the description. So if we say, join the Slack channel or something like that, you can check that out below. Which I do recommend joining the Slack channel if you want to stay connected with people in the community and talk more about AI. So today we have our guest, Michael, who's with us to talk about no code or low code machine learning, and if it's the future of machine learning. Michael, could you introduce yourself and tell us a little bit about your background?
Sure, Sage, and thanks for having me on. It's good to chat with you again. So I'm Michael Galarnyk, and my primary job is working as an AI evangelist at a company called R2AI AI, which is a subsidiary of Intel. So we work on an end-to-end AI platform that allows people to choose the best ML infrastructure for the job on demand. So basically, we're cloud neutral, hardware neutral, and really the point is about getting models into production and increasing value. So there's a lot of other things I do and have done. Like I've taught at Stanford Continuing Studies for a couple of years now. I've taught a machine learning class there. I've taught at UC San Diego Extension School, same sort of thing. My passion is really just blogging and content creation. So a lot of that is writing content. Sometimes it's consulting content for making content. And I also create some courses on LinkedIn Learning. So like most people here, and I'd like to hear what Sage's background is after I introduce my background, is my background, it was, previous to my current role, teaching data science and machine learning. So of course I mentioned, Stanford and UCSD Extension and other stuff like that. But I used to work in developer relations at Anyscale, which is the company behind open source Project Ray. If you haven't heard of it, you should. But basically it's a simple like universal API for building distributed applications. And I encourage you to check it out on GitHub. It's really cool. I really think it's the future of distributed computing. And basically my job there is really, I got to get paid for writing distributed computing blogs, making content. It was great. And then before that, I worked at Scripps Research, and I looked at long-term trends in like sleep, heart rate, activity. So I looked at a lot of Fitbit data, including the one I'm wearing today. And like a lot of people in data science, my degree had little or nothing to do with data science because it was in nanoengineering. So if you're familiar, depends on the subfield, I guess. But I worked on steering red blood cells with ultrasound, dealing with microfluidics, remediating nerve agents, and a lot of different subjects. So Sage, I mean, for everyone that's listening here, like, what's your background?
Before we get into that,
Yeah,
one
fine.
follow up on yours is what and I can tell my story of this. What got you into machine learning?
Well, economic realities is probably the simplest one.
Was there a
I
project
realized
or
I had
something that you were like, this is really cool, and that is
so
like what made you get more into it?
when I was working in microfluidics, one of my tasks was tracking particles underneath the microscope. And if you ever track particles, a lot of that is like image recognition, tracking speed, velocity, of hundreds of thousands, millions of particles, and you have a lot of data. In most fields, you have a ton of data, and so trying to do things in Excel, tracking velocity, displacement over time of fluid in a solution is really really hard. So instead of merging thousands of Excel files and dealing with whatever use case it was back in the day, Um, I learned pandas and I started getting into data science, and I learned there's a lot more cool things out there you can do with machine learning. There's a lot of the future really is machine learning for a lot of applications. So that's the basic way I got in, and then from there it just scaled.
Yeah.
So,
But I'll go a tiny bit into my
sure.
background and how I got into machine learning is so I used to work in hardware and doing like solid state lighting manufacturing, and then I worked at an IoT startup doing smart light switches,
Mhm,
and we had a really complex part that we were manufacturing, and it was hard to tell
mhm,
if it was good or bad. And I
mhm,
was like, I'm sure we could use computer vision to do this.
mhm,
And so then I just started researching computer vision and went down a whole rabbit hole there using machine learning. And that's kind of really what got me into the field. And then I just kind of kept going more and more into it ever since.
mhm,
And currently I work at a company called Y Labs. So we
mhm,
do ML and data monitoring, which is
mhm,
a really fun field to be in, which is kind of like, to me, it's the evolution of my career of like, I was building computer vision models and deploying them. Also
mhm.
working at a company that did some low code solutions, which we're going to be talking about that subject today, which is cool. But then it's like once you have those things deployed, how do you make sure that they're behaving as they should over time, and if there's any data drift or anything happening in production.
Yeah, it's all about keeping the value of the models. It's one thing getting to production, another thing keeping it there, scaling it.
Yeah, I think there's the joke of like I forget the percentage, right? Like people say like training the model is like only 50% of it, maybe
Mhm.
less or whatever. Deploying the model is only again a 50% of it. You have to have all the infrastructure in place.
Yeah, it's
um,
a lot, right? There's that famous image. There's a like 2014 paper from NeurIPS, I believe, on the hidden technical debt in machine learning. And like you see, like the challenges, with incorporating ML into applications, it's like configuration, data collection, data verification, and then like a small little like thing in the middle is like ML code.
yeah.
It's very tiny.
Which could be a good segue maybe into a no-code platform if it makes it easier.
Sure.
So before we really dive into like benefits or limitations, for those who don't know, maybe at a high level, what is no-code or low-code machine learning? Sometimes the both those terms get thrown around.
So I think the terms get mixed because I don't think there's often a lot of differentiation between low code and no code. But in short, if you're just talking about in general, the term no code is generally considered to be software development that requires no programming skills to quickly build an application. Ideally, quickly, I should say. And the heavy lifting is done by typically no code tool providers that use some sort of abstraction and encapsulation to hide complexity, um, so that the users of the actual no code tools can accomplish things. And this is typically through like dragging and dropping. Sometimes it's by working with an algorithm for no code ML. But the part where no code ML comes in is a lot of no code ML platforms, they really try to give users more time, and work with users that don't typically have as many like ML skills to provide value with ML. And I should note that most no code platforms can be considered low code depending on what part of the platform you're using, because a lot of vendors try to be, as open to a lot of different users as possible. So as far as like low code examples, I think H2O like has a pretty good low code AutoML, and it really has like a simple small interface for integrating with your language of choice for their like low code solution. So basically, for a lot of AutoML, for example, they do their best to automate algorithm selection, feature generation, hyperparameter tuning, and model assessment as possible, as much as reasonably possible, I should say. But I should mention, and we'll talk about this in a second, but like nothing is perfect. So a lot of these things use like pre-canned features, a lot of you know heuristics to try to get the best model of the gate as much as possible. But there's not as much observability for the user of these tools. So that's my brief definition. Does that kind of agree with yours?
Yeah, totally. I think so. And there's another like joke I've seen in the industry sometimes is like a lot of no code platforms at some point they become a low code platform because even if you're doing like the training and everything in an interface, a lot of times, not all the time, but a lot of
Mhm.
times at the end of it, you're probably interacting with some sort of API
Yeah.
to do it. So then at that point, you do need some code coming in. And like you said, not everything's perfect in the industry. And I think one way of like that I always have a comparison in my head is kind of like what happened with the web industry, almost like how people still program sites
Mhm.
all the time, like you're using Node.js and all these different frameworks, right, for all these really like high customization stuff. But then you have sites like Squarespace and
Mhm.
frameworks like WordPress that kind of opened up for a lot of people that maybe don't have as much web development chops, but they
Mhm.
can still go in and like build a website and do really cool things.
Yeah, and there's definitely some things you can't do with the no code solutions, or at least you can't. There's not as much flexibility with it, right?
Yeah, yeah.
Yeah.
So
So.
I think we already touched on it a little bit, but I think the next flow of this is like what are some of the top benefits of no code ML, and I think we already touched a little bit of like it kind of opens the gate up for people who maybe aren't machine learning engineers.
Mhm. I mean that the typical like way to say that is democratization of AI. I know it's a big cliche, but there's in theory at least a need for non-technical people to build custom AI solutions, or even just like automate some processes. And there's a lot of reasons for why this is important. One of them is that, I mean, from a selfish perspective, as a former data scientist, a current data scientist, whatever, is that it gives data scientists and engineers more time if more people can do AI. It also gives people better ideas of what's possible, what's not. If everyone can kind of understand a little bit of AI, how to get things to production, how ML works, how data is important, stuff like that. And it gives data scientists, if less technical people are working on the simpler problems, data scientists can work on the larger, more complicated projects, which no code MLs may not be as great for. But the one real cool thing about a lot of no code solutions that I think doesn't get enough credit is a lot of people that are technical actually do use no code or low code solutions to give themselves more time to quickly prototype. So even if they decide not to use a low code or no code solution, oftentimes they want to test a bunch of different models, want to do things efficiently, and a lot of no code solutions allow you to do things quickly and get things out the door as fast as possible because it automates some sort of process. Um, I should also mention that this is again for less complex use cases typically. So you can't typically use the most cutting edge ML models with um, low code, no code solutions because they're just less flexible and they typically have solutions for the most common sort of problems, right? Oh, and really quick before I get the stage back to you for a second, I should mention that there's a traditional like ML development steps, and there's kind of the low code AI development steps. So in both scenarios, you define a task, you collect data, um, but from there it really starts becoming different. Where in traditional ML, you do model exploration, refinement. Um, in no code, you typically do a lot of drag and dropping, you model training. Sometimes these no code solutions pick a bunch of different models for you and evaluate some sort of results and export the model. Whereas in traditional machine learning, you do a lot of stuff yourself. You define your own metrics, you deploy, integrate, and then monitor. In no code, a lot of stuff is kind of where it differs. Um, that's kind of my general thesis on that. How about you? What do you think about some benefits of no code?
Yeah, I think you hit on a really important thing too. Like, we talked about one of the benefits of opening the door up to someone maybe a little bit more non-technical. But I
Mhm.
think you hit like a really good point where even if I know how to program or use TensorFlow or PyTorch, that doesn't mean I always want to go and spend all this time getting that set up and
Mhm.
defining those architectures and like getting the data in and then saving the model and then putting that deploying it and
Mhm.
and running it that's not something I always want to do. So if there's like a no code solution that makes it easy for me to do the things I need to do, even as a technical person, if
Mhm.
that saves me like 50% of my time or more
Mhm.
sometimes, depending what you're trying to do, I would probably want to use that, right? If it has the flexibility I need to run my experiments,
Mhm.
and even potentially deploy my model
Mhm.
for my actual use case, like I don't see a reason why I wouldn't want to do that. as long as it has all the stuff I need, right? Like, and I think also, like, you kind of alluded to some things you were saying about like the data science and ML process. It's
Mhm.
not like you mentioned, a tiny bit of it's the ML code,
Yeah.
and even the infrastructure code, because like a lot of it's also asking the right questions, and
Mhm.
understanding, what type of data you need and maybe what type of model you need.
Mhm.
And no code can help with that too. Like if you don't know potentially what model is going to fit your data well, I know some of them have like the auto ML type features and stuff where you can kind of it can figure that out for you. But yeah, I think it's like if you know the how to ask the question and what type of problem you're trying to solve, then like I'd be excited to use a cool no code solution, and I've used them in the past, and yeah, it's great.
Mhm. And like anything, they get better all the time. Like, it's the same thing with if you use the old version of TensorFlow, like, version 0.8, 0.6, and now we're, wherever we are now, like, it's a lot better. It's a lot more usable. Same thing with a lot of like no code solutions. When I tried them back in the day, I'm like, oh, I don't know about this. Now it's like, oh, this is actually pretty cool. Like this is, not buggy. It works well.
Yeah,
Um,
yeah, I agree. Before we move on, I see a question in the chat
sure,
that might be fun to answer, and I don't know if you have a good answer for it, but
sure.
someone asked, is there a place like a GitHub awesome list for low code and no code ML apps?
So the one problem with, being this field is I don't have like a complete aggregated list at the moment for low or no code apps. I probably will just send you an answer. I'll just post in this comment section of the YouTube video after this is posted of, some things I find like, pretty cool. If you've had a good list too, feel free to share and I'm happy to post as well, or you can post. Do you have any great lists around?
I don't either, but I was going to
Mhm.
say that could be a great topic for a blog post.
Yeah, I'm down to do that. I'm down to blog. Always down to blog. This is
Um,
probably my favorite thing in the world is blogging because you can do it literally wherever you are. You can do it in an airport. You don't have to have a live internet connection. You can just, you know, go and blog.
yeah, and it's great type of content that
Yeah.
that can last for a long time usually too.
You can also update the content. You're like, oh, I found something I like a lot. You can, publish a post, then update it later, right?
Yeah.
My favorite kind of content. Um,
So I think we already talked a little bit about to the we talked about like the benefits, and I don't know if we want to go more into limitations. I think we've already talked about,
oh,
sometimes.
I think we should go more into limitations.
Right, let's do
Okay. So I have a bit of, a stickler for limitations because I like talking about the benefits and then also like the drawbacks. So it goes without saying, this goes with any cloud provider, this goes with any sort of software you have, is people try to avoid some sort of vendor lock-in. So vendor lock-in, for people that know, is just basically a customer signs up for a service or a product, especially if this happens to be a low code, ML solution that's paid. It's really hard to switch sometimes because a lot of the skills you learn with one vendor may not transfer to another tool. Um, that's really important because oftentimes a lot of solutions have some different assumptions between solutions. So like how someone would pre-process data or how a certain tool might deal with missing values by default, how things are deployed, what they monitor for, what kind of data is acceptable. Like these sort of things like matter a lot. If you're not like skilled in ML, you may not actually like account for this, right? Sorry, that's my rant of the century, but I have a lot more here. um, and I should also mention that for low code, and this is also in no code, um, there's a lot of, at least back traditionally, there were a lot of like black box models. So there's like a lack of visibility in some no code solutions. So if you really don't have a sense of what data is going in because you didn't explore the data yourself or other stuff, you might have a sense of what is a good output or is the output changing over time. We can actually talk about monitoring because I think it's a fascinating subject I want to ask you about, Sage. And this is a big problem because for some industries, you do need a lot of visibility into why something's happening. Because it gives, just even for regulation reasons, for like finance, you have to say why you're denying someone, credit or whatever. Um, and then we'll talk about the next limitations as we go. But Sage, I want to ask you, uh, what are your like major problems with low code ML, like particularly in terms of, like monitoring? Like you,
Yeah, I think like you mentioned too, it depends on the platform, and I've been seeing less of this. Like I think you said, traditionally there was a lot less visibility into
mhm,
everything, so it was kind of like sometimes even a black box model, like you're like not sure what model it trained. Like you might have an idea, but it's like you're like you want to know what type of model it is. You want to know the data coming into it. And I think I've been seeing a little bit more of that in some no code platforms too, about
mhm,
like better EDA or
mhm,
understanding your data. So like
mhm,
and you mentioned like monitoring. I kind of think of data monitoring, can start well before the training process, like most people do in EDA, but you kind of want to make sure like you don't have those outliers or problematic data and that the quality is good before you even train a model. So
yeah,
if there isn't a way to like easily ingest data or like I'm excited about the platforms that have really like intuitive cool ways of exploring your data
mhm,
before you train a model. So like if you load up a whole bunch of images and you're going to train a classification model or something like that, and you have these outliers in your evaluation data set or something like that,
mhm,
or looking at how things change at all the different points in the pipeline.
mhm.
I think that's really interesting.
Yeah, it's really important. There's definitely a lot of work that still needs to be done, but it's definitely gotten better in terms of EDA, seeing the outputs, understanding the outputs a little bit more. One thing I noticed a little bit more, as you kind of touched on, is some of these like no code or low code solutions. Um, it used to be like you have no visibility what's happening. Now, at least for a lot of solutions, there's explainability where they say like, here's the model we trained, here's why it worked best, here's what metric we used, here's the parameters, like here's what features we found important to at least try to give some um, like visibility into what actually happened. And there's also some platforms now that show the code of what they did to the data, what they did for training, et cetera, to try to give people some visibility.
Yeah, I think
Um,
that's super super important. I think going forward, in my opinion.
oh yeah, it's about bridging the gap where you can have a no code solution that's on prototype something and or even push to production, and then have a disconnect between the people that if they're like, oh, this is a great proof of concept, but we actually want to put in production and connect it to something else, and our no code solution doesn't allow us to do that. Well, you want to have a way to easily go from one to the other, and vice versa.
Yeah,
Oh, and I think we have some questions.
yeah. I was gonna say there's a interest. Someone has an interesting question. Is how do you think about assuring there are guardrails that prevent less knowledgeable users using no-code tools to do ridiculous things? And they said not that knowing how to code prevents that either.
Oh, I think we have a societal issue here. But uh, my opinion here, and I'll let you get to your opinion, is there should be some sort of training with these sort of solutions. Like there should be some data literacy. A lot of people have talked about like having basic data training to get people to kind of understand, basics of data, make sure that people, even for one thing, understand privacy of data, so that there's good things that go into a model, so that good things come out. That's a one really important thing. And the second thing is, a lot of this is incentivizing people that are less knowledgeable to become a little bit more knowledgeable, through incentive structures and corporations, um, so that people can better work together. Because a lot of, you know, uh, MLOps is more team based than I would argue a lot of DevOps because you have people from all sorts of fields working together. So that's just my opinion on this, and it can be completely wrong, and you'll be tuning out from it. But that's my general thoughts on this.
No, yeah, I think that sounds about right. And like one of the best things to do is educate people because, I mean, you might have people that are always going to be like bad actors,
Mhm,
and that's a different issue. I think of how to prevent or stop things like that.
mhm,
But I think a big thing, I think a lot of failures when it comes to ML making poor decisions, like it's not on purpose. It's people not understanding the data and the
mhm,
bias that's in their data. And I think you're right. Like having a lot of education built into a system would be
mhm,
really cool. So if someone's coming in and they've never trained a model before, as they're exploring the data set or something inside the platform, if it has stuff to call out, like what to look for and how to make sure your data isn't biased.
Mm-hmm.
I think that would be super important. And I think someone else mentioned that in the comments. They said that they have the same concern, and it's important to understand EDA, which is
Mm-hmm.
exploratory data analysis for people who might not be familiar with the term, and then the data distributions and correlations. And that could also be part of monitoring once a model is deployed or in the various stages to make sure that your model isn't biased in
Mm-hmm.
the future, right? So like you could deploy a model and hopefully you would already know a lot about your data and expect it not to be biased, right? But like
Mm-hmm.
there we have a saying that I've heard before that is bad things happen to good models. Like you can deploy
Mm-hmm.
a model and it's great, and then the real world changes over time and it doesn't know how to cope with that, and then
Mm-hmm.
it's going to be making bad predictions, or potentially biased predictions. So it's important to like monitor over time once it's deployed, I think.
Yeah, and I'll be sharing a couple of resources of like some really bad screw ups during the beginning of COVID for models because the assumptions of the models changed. The world completely just changed all of a sudden. People making different algorithms for financial markets, for plane bookings, just like the data changed, right? And you have to have ways to monitor things that change quickly and have quick logging and quick notifications and alerts. Um, because otherwise you can lose a lot of money, time, you can do some horrible things, and cause collapses.
Yeah. I think, yeah, COVID was such a good example of a lot of our systems just not being ready for a big change like that.
Mm-hmm. That's a really important reason you need to monitor. Really important. And there's obviously there's silent errors too, or silent mistakes too. The data changes, and in some way you don't understand, or like the data columns change, or the way data is entered, or there might be some like future data put into current data in the future, and just like weird stuff, which I should not even go into. But
um, so before we move on, because we're
Mhm,
getting a little close to our 30 minutes,
mhm.
so do you think the future of machine learning is no code, low code?
So, like anything, I think we try to be one thing or another. I think it really depends on use cases. So, for assisting with data labeling, and I see you were at Plain Sight before, um, that it's really useful. If I mean, assuming you assume Plain Sight, data labeling is no code or low code, it's very useful to like assist humans. There's a lot of things that you absolutely do need some low code, no code solutions to help speed up processes, right? And then there's murky areas where um, you can do basic models, but for the really cutting edge things, I think there'll still be a need for traditional machine learning workflows because a lot of no code or low code solutions aren't really built for the corner or edge cases or the cutting edge necessarily because not a lot of people are doing that at the moment. How about you? What do you think?
I think, yeah, I think it's going to be a mix.
Hmm.
And I think I brought up this analogy before, but I could see it being a little bit of like the web, right? Where
Hmm.
there's tools where a lot of people might be using a no code solution to build these
Hmm.
models, even if they're not deploying it, but maybe they're training models and running experiments before that. But I think there'll also be a lot of people, programming custom solutions and, building out custom infrastructure within their companies to do all the things they need to do. So like you mentioned data labeling, having auto label stuff like built into your pipeline to help your data. And we've seen there are tools that can help you
Hmm.
do that now too, even on the no code side. But I think there'll always be some room for
Hmm.
custom stuff within companies.
Yeah,
So
of course.
I think it'll be a mix.
Yeah, and even like if your entire process isn't, no code, low code, there might be some parts that are, no code. Yeah, for data labeling, it might be you have a no code solution for monitoring. You could have, a no code solution for, just training itself. It depends on use case.
Mhm.
So, well, I think it'll be a hybrid in the future.
Yeah, and yeah, there could totally be a mix in your infrastructure.
Mhm.
Like you could be using a no code tool for part of it, and then you go in and your deployments aren't a no code or something, right? Like there's a lot of like I think it's another cool layer to the tool set that we can use in the industry.
Yeah,
Um,
awesome.
all right, and then before we're kind of wrap up, I had one other question. Is
Sure.
you've done so much to teach people machine learning and data
Mhm.
science through all of your awesome things that you talked about, like Stanford continuing education, LinkedIn Learning. I know you've
Mhm.
done a lot of blog posts. What is your advice for someone looking to also get started creating content to teach others in a similar way?
I think the biggest thing is get started. I mean, you don't have to do anything complicated when you first start. Like the stuff I originally started writing about was like like installing Anaconda or like, getting started with AWS, like EC2, like nothing really that complicated. You can start small and you can always publish something and, update if you're doing like blog content. You can always make YouTube videos and, your initial ones may not be as popular as your, ones that you do over time. You get better over time. It's like anything, right? 10,000 hours of practice or so. It's really important. And then once you have something, you get started with, you can do more complicated things. I think we always try to start off, with the most amazing content and, work away from there, but it doesn't always happen like that.
And you mentioned blogging, I think, being your
Yeah,
favorite type of content.
by far. Like I'm trying to get away from the live teaching stuff to get more just into content. Because it's what I like to do more, I'd say, because I can write literally whenever. I can wake up in the morning, write a little bit, go get lunch, come back for 15 minutes. I can be waiting in the airport or even on a plane and be writing. No one can ever take it away from me. Whereas teaching, I need an audience typically. Uh, I need to have, I need to do the other stuff with, teaching, with the video editing, answering, emails for things that aren't always related to teaching. So just my opinion, my desires. So,
Totally, yeah, yeah. Everyone has different things they like. Like some people love doing live
mhm,
streams. Some people like recording videos. They're all
mhm,
really cool. And yeah, just to add on,
mhm,
to doing content, like you're saying, you don't have to start doing something super advanced. And
mhm,
there's almost always someone who knows less than you, or
mhm,
they don't know about the specific topic. And sometimes being new to it can be really helpful because you can write from that perspective.
mhm. Because some things that people think are inherently obvious are really not. And that's a really good perspective to come from. And you also learn by writing and teaching and all that sort of stuff.
Yeah.
I know I wouldn't have gotten the jobs I've gotten without having an online presence, having written blogs or made YouTube videos, which were pretty terrible back in the day. I can share some bad videos of me doing content, but um, it's really a great way to get your foot in the door in a lot of places. And if you really want, you can go all in and become a developer advocate or whatever later on. But
Which is in my opinion, a pretty fun role to be into, and I think you might share the same sentiment towards it.
yeah, I mean, that's what we're doing right now. We're evangelizing.
um, so I know we're, I think, slightly over
That's
our
fine.
30 minutes, but I totally want to hand it over to you and tell us about anything you're working on. I know you've been doing things like events, obviously content. Do you have anything you want to shout out specifically, or um, let people know where to find things?
So I've been doing a lot of different things. Lately, of course, writing a blog. You can find it on Medium. Just type in Galarnyk Michael or Galarnyk, you'll find me pretty easily. And I typically write about basic things, train test split and excruciating, uh, lots of detail, PCA, box plots, whatever. Um, I've also worked in R2AI AI, and what we work on is an end-to-end ML platform that whatever your data is stored, wherever compute you want to use, we work on making the most efficient use of the compute that you have to quickly get your models in production, as well as monitor that they actually are still working. Um, of course, we use a lot of open source tools to help accomplish that. Um, and currently, I'm also working on a no code ML solution called AI Blueprints, which is not quite GA yet. But essentially, what it allows people to do is try to democratize AI to people for whatever compute you use, for whatever use case you want, to try and make it so, oh, I want to do something for recommendation systems. Well, here's a blueprint to help you get started and to help you, get your recommendation system going for whatever you happen to be doing. It can be recommendation systems, NLP. It could be simple classifiers, whatever you want. And that's a lot I do. And follow me on Twitter, of course. So, how about you, Sage? What are you up to these days?
These streams. So thank you so much for coming on. I think was there one other event you had coming up?
Oh, In August 10th, I'll be doing an O'Reilly Superstream. I'll be one of the speakers talking about building data pipelines and connectivity. And so I'll be talking about basically low code ML and kind of the intersection between data pipelines and ML in production. And it'll be a lot of fun. I encourage everyone to come. If not, that's cool too. Feel free to connect on LinkedIn, et cetera, et cetera.
That's awesome.
Yeah.
I'm excited to go see that because I know I'm an O'Reilly subscriber, so I think I even got the email saying I should go check out the super stream, but I didn't know you were in it originally.
Yeah, I have to be at all these events these days.
That's awesome. And then, yeah,
Next time.
for anyone watching, all the links to Michael's social are in the description too. So if you want to go check out Medium, like they mentioned, or LinkedIn, you should be able to find that in the description below. But with that, I think we're going to wrap up the stream. And thank you so much again, Michael, for coming on. It was awesome to talk about everything from no code and low code ML to creating content. And thank you again.
Okay, have a good one, Sage.
I'm going to end the broadcast for anyone watching.